Hello and welcome to this tutorial video. Actually, this is a continuation of the manifold analysis, and this is the post-processing of this example here. I will show you some different options in post-processing, like the adding lights or creating isosurfaces, generating velocity vectors, different type of contours, also animations and XY plots. So let's get started. Okay, first of all, we need to show our geometry, so we can use this option here, display meshes. You can also select from here domain and display. So first of all, I will display and discuss about different options. So if you see here, this is our geometry. Here, 3 inlets and 1 outlet here. You will see the meshes is also displaying here on the surfaces. This is because this edges has been selected. So if I deselect this one, you will see only the surfaces. And in this case, we just select the wall surfaces as these ones are the wall categories under the wall. If I select this inlet also, you will see here the inlets. These arrows will be deactivating by this option. I can use this one. In this case, I don't need these inlets, and I just want to show the walls. And there's another options here, colors. If I select these ones, there are two different options, by type and by surfaces. In this case, you see this is selected by type. So as these are the wall surfaces, so these are in the gray color, preferred color actually. But if I change to the by surface, close this one and display, you will see each each surface is separated by a color to distinguish the different surfaces here. But in this case, I just need to use by color, close display again, and I will also check the edges here and then this display to show here. I will close this one. Here you also access to some options for the view. So I will just select the isometric view here. You will see like this one. Now we can go switch to the adding lights to our graphics. For this option, you just go to view options and the lights here. Okay, so there are different options. I will explain you actually. The default light setting, add a white light at the position of 111. The default light is defined in this light dialog box by the light ID here, 0, with direction vectors of XYZ at 111. Okay, just being sure that this light on has been selected as in it is enabled. You can use this automatic for the lighting mode and headlight on the on, and then apply, and you will see the differences. It seems that there is some lights here, and this is a shadow in your display. Here also there are different options. For example, this flat is the most basic lighting, whereas this growth gives better color graduation actually. Now I will add two more lights in two directions. So for example, first of all, I will change this light ID to 1, make sure that this light on is enabled. Then I will enter -1, 1, -1, 1, and 1 for x, y, and z, respectively in direction group boxes here. And then I will retain this automatic and this on here, and then apply for this one. You will see there is another lightning. Similarly, I will add the second light with the light ID of 2, turn on, light on, and then these two options, automatic and on, is this enable actually, and then I will add -1, 1, and -1 again here. Let me try, is it working or not? But I will apply here, so you will see another light in another direction has been added to our graphics. So let me close this light window. Next step is creating some ISO surfaces. Actually, to display results in a 3D model, you will need surfaces on which the data can be displayed. Fluent creates surfaces for all boundary zones automatically, but you can define additional surfaces for viewing the results, such as a plane in Cartesian space, for example. In this exercise, I will create a plane cutting through the middle of the manifold and at the outlet also. I can use these surfaces to display the temperature and velocity fields. So let's start for creating some ISO surfaces. Okay, so we need to go to the results tab, and then in the surface options you have this create tab. You will go here and then select ISO surface. There are different options, but in this case I'm using this ISO surface. So I will bring this window here, extend more visibility. Okay, so first we need to write a name. In this case I will use outlet plane for this ISO surface name, and then from one surface we need to create this ISO surface. I will select mesh surfaces, and in this case for me I will go to the Y coordinate. Then here there's an option named compute. So if I click here, so you have access to the minimum and maximum Y coordinate of your geometry. In this case you will see Y is in this direction, so here the minimum, and this is the maximum actually Y direction. So I just use this one as my ISO surface -125.0188 here. So this is my ISO values, and now I can create this surface name outlet plane. So before that, let me go to the outline view. Here we don't have any surfaces. I will create this one. So you will see now I have this new plane, outlet plane. I can display this one. So this is the new created plane, but I can display again my geometry and close this one. So now I have a new surface named outlet plane created from the ISO surface. Next ISO surface is in the X direction. I will call it mid plane X because this is in the middle of this geometry in the X direction. So in the surface of constant I will use mesh, and here I will go and select X coordinate. Actually the same process I can use to just check the minimum and maximum of the x direction. This is the minimum and maximum x coordinate is between these two values. I will just select 174 for this mid-x plane, and I will create my surface here. And this is the new plane I will display in this geometry. I can also add this one to this active window, the previous created surface. So I have these two new created surface together to just check. This is the minimum value of the y, and this is in the middle x coordination. I will go again to display my geometry, close this one. So now I can close this ISO surface window, but for the next surface I'm going to use another option here, ISO clip. So I will select this one. First of all, this is in the Z coordinate. I will call it clip in the Z coordinate. I have my clip surfaces here, and for the value I will select mesh and then Z coordinate. So it is ready to select my surfaces. In this case, I will select this solid up 1447. But the thing is, maybe this number may be different due to the mesh generation, and in each, I mean, everyone has some different name here, but you can check there is a shadow wall also here, so this one should be selected, but I can also check in the boundary condition this one, and if I just display, yes, this is the wall that I need to select for my ISO clip. Okay, so based on this one I can compute my minimum and maximum. So this is the minimum and maximum values here. I will just keep this maximum value as -18, but I will change this minimum to -44. So you will see between, minus, and this is Z coordinate. So if you see here, this is my 0 point, origin point of this Z, and this is the positive value. So I have selected from here -44 to -80 actually in the general dimensions. So I can create this surface also. So I have this clip that inner I can display in the graphics. I will go back here and then select and display, hold my geometry. I can close this one, close here. So now I have 3 new surfaces under the resultant surfaces. One in the Z coordinate, one in the middle X plane, and one is here in the outlet plane at the bottom in the Y coordinate. So based on these new surfaces, I will go and show how we can generate our contours. For the first contour, I will display field contours of temperature on the mid plane and also on the outlet. So let's see. First of all, let me close this one, and in the graphic you see there's no contours here under the graphic and contours. So for contours I will again work on the results, and then under the graphics I can select contours and the new contours. I will call it as the contour temperature, and as I said, this is a field temperature contour, so I will select this field option. Then my contours of a temperature contour, and this is a static temperature. So I will keep it as a static temperature here. Then let me expand this window. Deselect first of all the surfaces. Then I will select this isosurfaces, mid-plane X and outlet plane here. Then I will select this draw mesh. I can enable a mesh alongside the contours to see both contour and mesh together. Now let me first close this one. I need two more ISO clip through the manifold geometry, so I will create those one as well. We'll close this one. So I had created these two before in the previous tutorial, but I will create again here. So I will select the ISO clip, name it as the clip X coordinate here. So I will select mesh X coordinate also, and then select the solid up one here, and then compute. Then this is the values, minimum and maximum in the X coordination. I will keep this minimum value, X coordinate here, minimum value, and I can change this maximum to half of this X. Actually, I can also use this one to have the something like this in the middle, actually. Okay, like this one. Then I can create my clip X coordinate. So now I have this clip X coordinate also here. Another one is a clip on the Z coordination. I will call it clip Z coordinate. Use mesh and then Z coordinate. The same surface, solid up one, and then I can compute the values, minimum and maximum. I will keep the minimum here in this case, and I will change the maximum to -44. So this is this white one is my clip Z coordinate. So I will create this one as well. I can close this one and then go to create my contour. Okay, for the contours, I have this option here and the graphics, contours, in new. I can extend this one. So now I have this X and Z clip coordinate also here. I will call this contour as a contour temperature, and this is a field contour temperature. So I will select this field option also here. So first of all, I will deselect all the surfaces. Then I will select mid-plane X and outlet plane here. As I'm going to show this contour beside the some part of geometry, I can draw some geometry and mesh here. So I will select this draw mesh first here. Then just be sure that these two options, edges and faces, have been selected. Then here I need to deselect all the surfaces here. I will just use these options here, and then I will select the clip X coordinate. I can display here. So this part has been displayed here, and then I will close this one. So now I can create my first contour temperature. Use the save and display. So after a while, you will see this temperature contour here, and the temperature, static temperature, legend also has been shown here, and you have your geometry and the contour both together. And in the contour part here in the graphic, you can open these contours and you will see you have a new contour temperature here. Okay, now I can close this window. I have this contour temperature here. So I'm going to show another temperature contour. In this case, I'm going to display a field contour of temperature for the surface of the manifold. So I will go to the contour and select a new contour here. I will call it contour temperature manifold. But in this case, I will deselect the global range and then select the walls, all the walls here, and then save and display. So here I have just deselect the global range. So this legend of temperature and this temperature minimum maximum is only for this selected walls here. But you can see, for example, if I use the global range, this contours will be in the range of minimum maximum of all the geometry, so it is a little bit different. So I don't need that one. I just need the global. I deselect global range to have the temperature contour bit in this all wall surfaces. So I will select this one here. Then I can close this one as well. Okay. So next step is generating velocity vectors. As you know, velocity vectors provide an excellent visualization of the flow through this manifold, depicting details of the flow structure. So let's start to create a new vectors. Here you see there's no vectors, so let's see. Okay, again in the results we have these vectors. I can just select the new here. I will call it as the velocity vector here. Okay, then just ensure that these three options has been selected: global range, auto range, and auto scale. Scale is one is enough and good for this velocity. Just let me extend this window and then deselect all surfaces and then select the midplane X actually here. We'll select this one and then I can save and display. So this is a view of this vector here. I can just go select this one. These are the velocity vectors, and just be sure that this vectors of velocity and this colored by, is velocity and velocity magnitude in this case. And this is the range of the velocity vectors. This is the global range, so this is a minimum maximum of whole the domain. So you will see this is the outlet and maximum level and the minimum in the inlet. Then next, I will plot the velocity vectors along the mid-z direction plane manifold. Let me close this one. So here also you can see the new velocity vectors has been created here. Again, I will go to the vectors, new vector here. I will call it velocity vector 2. Then I will enable the draw mesh option here. Then I need just the faces, so I will deselect the edges here, deselect all the surfaces, and then I just need to select the clip Z coordinate here. So I will select this mesh in the graphics. Then I will go and select this color option. Okay, here. So I will select these options by type, and then in the types I will select the surface here, and I can select, for example, light blue here in this colors option, light blue. I will select this light blue, and this is a sample of this light blue options. Then I can just close this one and then display the mesh. So this is the mesh. So let me go to the isometric view like this one. Then we'll close this window here. For this case, I will select in the style, I will select these options, arrow. There are, as you see, there are different options. I will select just this one, arrows here. For the scale, in this case, I will select 5. So the size of these arrows will be scaled by 5. Then I will deselect all the surfaces and then select midplane Z here in the surface selections, and then I will just save and display. You see the draw mesh is enabled now like this one. So yes, that's it. You see the arrows of these vectors has been scaled here. But in this case, it is better to show these vectors in another plane, like Z plane. So let me go and create another ISO surface in the middle of the Z plane. So I will go to this results surface, create ISO surface here. I will call it as the middle plane Z. Then select the mesh, the same procedure, and then Z coordinate here. In this case, I will select both fluid 1 and solid up. So for these two zones, fluid and solid, I will use the compute button, and for the ISO values, I will select -44 in the Z coordinate. Now I can create my mid plane Z. This is a plane in the -44 between minimum and maximum of the Z. It is placed here. So I can create this one. Then now, as you see, I have this mid plane Z. I will close this one, deselect this one, and now I will select the new plane, mid Z plane, save and display. So you will see this is a new velocity vectors with the scale of 5 of the arrows, and you see the pattern of the flow from inlets to only outlet here, and you will see the velocity magnitude here. So okay, for now I will close this video for this tutorial. I will continue in the next tutorial for another part of post-processing from the same actually Fluent